Greetings, Mindsetters! You're here today with me, Megan, and welcome grade 12 to today's maths show. Today we have a special revision lesson on algebra prepared especially for you. We'll be selecting highlights from the lessons shown early in the term to help you revise for your end of term tests. You can download the notes for today's show on learnextra.co.za/live.
Now, the question says to simplify the following, and it would be without a calculator. I have to say that nowadays, you guys all have calculators, you all know how to use them, but imagine you're stuck on a desert island and you really, really need to know what the square root of 75 is. Well, this is what you're going to do. For me, the easiest is to break the number down into its prime factors. So I'm going to list my first couple of prime numbers, 2, 3, 5, obviously after that 7, 9 is not a prime number, remember. Okay, and I'm going to say, does 2 go into 75? No, it doesn't, but 3 does. So I take the next one, and 75 divided by 3 is 25. Now, I know that neither 2 nor 3 go into 25. Now I'm going to say 5 goes into 25 5 times, and 5 goes into 5 once. Then I know if it's a square root, for every 2 numbers that are the same, I can take 1 out. If it's a cube root, for every 3 numbers that are the same, I can take 1 out. If it's an nth root, for any n numbers that are the same, I can take 1 out. So you might want to just quickly do this, show your teacher that you're not cheating. So for every 2 numbers that are the same, I can take 1 out, so I can take out the 5. And I'm left with root 3. So 5 root 3 is the simplest form of that one. Let's have a look at the next one. For the next one, we've got to simplify, again without a calculator, the 6th root of 64. Now guys, on your calculators, your calculator can put the number into prime factors for you. There's a function on the calculator called shift fact. You guys might want to try that out. Probably most of you know that. But doing it the old-fashioned way, 64 divided by the first prime number, which is 2, I'm left with 32. Next prime, I can still use 2, I'm left with 16. I can still use 2, I'm left with 8. And 4, and 2 goes into 4 2 times, and 2 goes into 2 once. Now, I said to you guys, for every n numbers that are the same, you can take 1 out. So now I've got 6 2's, and I'm looking for the 6th root. So I can quite simply just say that the answer is 2. Another way to do this would be to say, this is 2 to the power 6, everything raised to the power 1 over 6, and then, of course, the 1 over 6 and the 6 cancels, and I'm left with 2. Right. I think there's one more. We might as well do it quickly. They are so quick. So the next expression is 8 minus root 80, everything divided by 12. Guys, again here, we're dealing with that minus sign over there, so please make absolutely sure that you don't cancel over a plus and a minus sign. Let's have a look at what I'm going to do here. I'm going to leave the 8 for now. That looks absolutely horrible. Let me rewrite that. So I'm leaving the 8, and I'm going to look at the prime numbers, prime factors for 80. So I'm going to say 2 goes into there 40 times. 2 goes into 40 20 times. This is hardly hard. 2 goes into 20 10 times. 2 goes into 10 5 times, and 5 into 5 once. So because it's a square root, for every 2 that's the same, I can take 1 out. So I'm going to take out a 2 times another 2. So I'm going to have 8 minus 4. And because the 5 doesn't have friends, it has to stay underneath the square root like so. Right. So that's all divided by 12. Please, guys, no cancelling over a plus and minus. We're going to factorize. So I'm going to take out the highest common factor at the top. I'm taking out a 4. I'm left with 2 minus root 5. And that's all over 12. And then I can simplify. I can say 4 goes into 4 once, 4 goes into 12 3 times. So I get 2 minus root 5. Oops, almost made it 3 root 5 over 3. The next question asks us to express each of the following expressions as a single log and to simplify where possible. Okay, so guys, very, very important. We've got our 3 log laws that we can use. We've got 3 log laws that we can use, and we're going to start now. Now, it's a very useful fact to note that if we have log to the base a of a, in other words, if I can get those 2 numbers to be the same, then it is equal to 1. So that is something that I'm going to try quite frequently in my questions. I'm going to have a look at my base and I'm going to see, is there a way that I can get this sort of situation going on where those 2 are the same? Because then I know that the answer is 1. So let's have a look what we're going to do here. I'm going to start out. And guys, remember there's more than one way in which to do these questions. And it's not necessarily a right way or a wrong way. We can all get to the correct answer in a different way. But I'm going to be quite tempted to write the 9 as 3 to the power 2. Right. And then, similarly, for the 27, I'm going to write it as 3 to the power 3. And maybe I should just mention, guys, at this point, if you have a log with no base, if a base is not written there, then the base is 10. All right, so just remember that. I didn't mention that before. Okay, so all I've done really now is write the 9 is 3 squared and the 27 is 3 cubed. What I'm going to do now is take that 2 in the exponent and move it to the front using the 3rd log law. So this is going to be 2 log 3 of 3. And that guy is going to come to the front as well. All right, so now I know that this section that I'm putting into the purple brackets, that is equal to 1, because I've got this situation going on where I've got the same A and A, or in this case 3 and 3. So then this just becomes 2 minus 3, which is equal to negative 1. All right. There is another way in which you could have done this question as well. Let's have a look. Perhaps some of you would have done it like that. We could have also used the 2nd log law. Now, the 2nd log law is the one that deals with the minus. Let me just write it down quickly. It's the one that says, if I have log of A minus log of B, I can write it as log of the first over the second. So perhaps you guys were quite tempted to do that, and that you could have done quite easily as well. So you could have combined the log from the beginning. No problem. Right, let's have a look at another example. The next question asks us to do something similar, but now they've just made things a little bit more interesting by putting in m's and things. So let's look at the instruction again. Express each of the following expressions as single logs and simplify where possible. So we're not necessarily always going to be able to get rid of our logs, but a single log is also considered a decent simplification. Right. So let's have a look here. Now, I've got 7 log m minus 2 log m. Now, guys, this is much the same as having 7x minus 2x in algebra. They are like terms. They are both m's. It's not the same as the last one, though, because that's 2m. So I just need to pay attention to that. So I can immediately simplify my situation quite drastically here by saying 7x minus 2x is 5x. So 7 log m's minus 2 log m's will be 5 log m's. So I've got 5 log m plus 3 log 2m. Now remember, guys, I said to you, all of the log laws can be used in reverse as well. So if you have log a to the power x, you can write it as x log a. In other words, you can take that exponent and put it in front, but you can also do the reverse. You can take something that's in front and put it back into the exponent if that happens to be convenient for you, and it definitely is going to be now. I want to apply the first log law, which says that log of a plus log of b is log of a times b. But I first need to get rid of these guys in front here. So what I'm going to do is I'm going to move that 5 back into the exponent position. So this is going to become log of m to the power 5. Right. And I'm going to do exactly the same thing here. I'm also going to move the 3 back, but now I must remember, perhaps put a bracket that makes it easier. Just remember that that 3 is involved in both the 2 and the m. So a bracket really is a good idea. I think that would probably be where most people would make their mistake in this question. Right. Now, before I apply the first log law, let's just do this. I'm going to say this is log of m to the power 5 plus, now remember it's 2 to the power 3 and m to the power 3. So this is log of 8 to the power m cubed. Right. Indy, how are things looking?
I
People
might
following
even,
so far?
They are. I think I have a question. This one's from Chafikwa, and
Yeah.
she asks, okay, so what if we have log 3, and is it log 4, right, log 3 minus log 4 minus log 3 plus log 5? How will I simplify that? Will I still use the multiplying by the reciprocal rule? Question mark.
What I'm going to do is I'm just going to finish this one off, then we'll write it down and we'll see if we can help her through.
Okay.
Okay, so now what I'm going to do is I'm going to say, instead of saying log of a plus log of b, I'm going to say log of a times b. So let's do that. And that is then m to the power 5. I'm afraid my 5s are looking a bit like 6s, but never mind, times 8 m to the power 3. And then, of course, that can be simplified. Remember, the whole point is to have a single log. So that's log 8 m to the power 8. Power 8, of course, because I'm adding the 5 and the 3 together. So once you know what you're doing, it really isn't that much of an issue. So let's have a look at, what is it, Rafique's question?
Yes, let me have a look.
Okay, what if you have? Okay, let's see. Let's hope it can be simplified.
I hope so. I was hoping that my page will load faster. It's getting there.
Well, so we go on to the next question until...
No, I think I've got it here. I've got it. Okay. So what if we have log 3 minus log 4 minus log 3 plus log 5? And she wants to know how she will simplify that.
All right. Well, the first thing that I would do is I would use the whole like terms scenario. I'd say I've got log 3 and minus log 3. So they would cancel out, like x minus x. So that's already quite useful. And then I would write them this way around. I'd say log 5 minus log 4. And then I would use the division rule and write that as log 5 over 4. You're not going to get the log to cancel out, but at least you've simplified it down to a single log.
Let's go to a short break now. Remember, if you are struggling and you need help, remember to post your comments and questions on our Facebook page, facebook.com/LearnExtra, or on Twitter @LearnExtra. Don't go away. We'll be right back. Welcome back, guys. Let's get into some more revision. Over to you.
Exactly.
Right, so I've got our first question on the board for us. So let's have a look at what it says. I'm going to go really slowly, yes, because I want to be absolutely sure that you guys know how to approach these questions. Right. It starts with given the sequence, and we've got 26, 24, 22, and then ... -12. Now, before I read any further, I'm going to make the decision arithmetic, geometric. Now, this one is a bit of a no-brainer. I think most of you will be able to see that to get from 26 to 24, I am subtracting 2, and to get from 24 to 22, I'm subtracting 2 as well. You only need 3 terms to be able to determine whether it's arithmetic or geometric. So, the first thing that I would write down for myself is that it's arithmetic. And remember why 22 minus 24 is -2, 24 minus 26 is -2 as well. Now, whatever you do, don't start using the formulas for geometric. It's just not going to work, trust me, I know. Right, so let's have a look a little bit further. They say, determine the number of terms in the sequence. So, according to the question, the sequence starts at 26 and it ends at -12. And obviously, a whole lot of things had to happen in between so that you could get to -12. So they want to know from us, how many times do I need to repeat this process of subtracting 2 in order to get to -12? Now, guys, the bad news is it's not going to work to just sit on your calculator and go -2, -2, -2, -2. You have to use the formulae. Right. So the first thing that I'm thinking about is, which of the 2 formulae will I use? Will I use sum or will I use term? Now, there has been absolutely no indication to me that I might have to use the sum formula. The word sum was not mentioned. I didn't see a plus sign, and nowhere were there words like total or altogether. So I'm selecting to use the term formula, which I'm now going to write down. So now's the time to fill in what I have and what I need. Now, my unknown term, my term that I don't know the number of, T question mark, also known as Tn, is -12. So -12 is placed in the place of Tn. There I put my -12. Right. As I mentioned before, A stands for the first term, and the first term is 26. So in it goes, plus, and then n minus 1, and my common difference from one term to the next, that's -2. Indy, I'm just going to go to you for 2 seconds just to find out if we got any questions so far.
Okay, let's have a look. Looking. Cabello has said to me that I must say hello to you, Liesel. So Cabello says hello and says,
I've
don't...
got Cabello's question for later on. I've actually got it. Yes, he emailed it through earlier on. So
Yes,
Cabello will get to you next.
Your question lives, Cabello.
I hope it's the same one. I hope it's the same one. There might be more than one Cabello out there. All right, but there's no questions so far, Indy?
No, nothing that is... What I want to say to the mindsets is, guys, if there's anything that Liesel's going over that you don't understand, let me know on the Facebook page. Try and not post new things that we will be going over. Guys, we will cover everything throughout the year, but let's just, let's go through sequence and series today, sequence and series questions, and post now.
All right.
Yeah.
Okay, so let's get on with it. There's no problem here. The rest we have to do is very straightforward algebra. I've got my 26 over here. I'm going to say -2 multiplied by n, so that's minus 2n. And -2 multiplied by -1, that's plus 2. Right. So I'm going to, you can do it any way you want. I'm going to put my 2n over here on this side. I like having those on the left-hand side. And then I've got 26 plus 2 plus 12 on the right-hand side. And that gives me that 2n is equal to 40. So n is equal to 20. So there's 20 terms in the sequence. Or if we repeat the process of subtracting 2 from 26, we will get to minus 12 after 20 times. Now, guys, it's very important that we remember that n is like a place in a race. Your answer has to be a positive whole number. I can't say that you're such a terrible athlete that you came minus 20th in the Comrades, right? That doesn't work. I also can't say, oh, I'm so excited, the Bafana were minus 2th in the AFCON Cup, or 2th in the AFCON, 2.5th in the AFCON Cup. So it has to be a positive whole number. Right, so pretty straightforward. Whenever they ask us the question, which term or how many terms are there in the sequence, we will substitute our unknown term in the place of Tn, and we will be solving for n. Right, this question gets more complicated rather quickly. There's a second part to it. So let's have a look. The next question still deals with my same number pattern, 26, 24, 22, all the way down to minus 12. And it now says, how many terms must be added to get a sum of minus 1,224? Now, guys, the words added and sum indicates to me that I will be using the sum formula. Please, it's still the same number pattern, so I'll be using the sum formula for an arithmetic. Let's write that down. Now, it's an interesting question here because every time I have to work out how many terms. So in both of these questions, the unknown that I've had to solve for is n, how many terms. Now, it's not so tricky if you're dealing with the term formula, but it can get a little bit more tricky, just the algebra, if you're dealing with the sum formula. Let's get on with it. Right, so how many terms must be added to get a sum of minus 1,224? So my S unknown, how many terms must I add to get that? Also known as my Sn, is then minus 1,224. So minus 1,224 equals. Now I'm solving for n, so don't freak out. Don't worry about the fact that there's nothing in n. And please, whatever you do, don't put minus 1,224 in the place of n. That's just going to be messy. Right, so on with the algebra. 2 times a, my first term. Remember, the first term is 26. And plus n minus 1. And my common difference from one term to the next, I subtract 2. And remember to add in this minus, guys, because it's just really not going to work out at all if you don't. Right, so now I'm just going to do a little bit of tidying up here. It's kind of like washing the dishes after supper. What I'm going to do is I'm going to work from the inside out. So I'm first just going to deal with my bracket. I'm going to say, all right, 2 times 26 is 52. Then minus 2 times minus 1 is 2. And minus 2 times n is minus 2n. Okay. So some more housekeeping inside my bracket, guys. You really don't have to show this many steps. I'm just trying to make it as easy for everybody as possible to follow, but you don't need to stress out. Now what I need to do is I need to distribute my n over 2 into the bracket, and that's not going to be hard. I'm going to say n over 2 times 54 over 1. Remember, it's over 1 like that. 2 goes into 54 27 times. So I get 27 n, and I get negative n squared, And what happens is that the 2 and the 2 there cancel each other out. Right. Now, you guys should be able to see that what I've got forming here is a bit of a trinomial. Right, so I'm going to multiply out until I get my solutions here. It's going to be n squared minus 27n minus 1,224 equal to 0. Now, guys, this is a bit of a difficult quadratic to solve. I don't know about you guys, but I'm not that well versed on the factors of 1, 2, 2, 4. But what can you do? You can, of course, use the quadratic formula. But just to save us a little bit of time, I've gone and looked it up for us. So it's n minus 51 and n plus 24. Right, so remember, your quadratic formula is what you will use here. Now it's time to write down our answers. Now our answer is either 51 or it is negative 24. But now remember, guys, what did I say just now? N is like the place in a place in a race. You can't be so bad that you came negative 24th of. So the negative answer you can just lightly cross out or write underneath it, not applicable. Right.
Let's go to a short break now. Remember, if you are struggling and you need help, remember to post your comments and questions on our Facebook page, facebook.com/learnextra, or on Twitter @learnextra. Don't go away. We'll be right back. Welcome back, guys. Let's get into some more revision. Over to you.
Right, now this is quite a tough question. It's not geometric, but it deals with sigma notation, and we haven't really spoken about sigma notation just yet, so I think this is a very good question to talk about. Basically, it says to me that sigma sign means to sum. So the moment you see the sigma sign, you must know that you are going to be using your sum formulae. Either the sum formulae for arithmetic or the sum formulae for geometric. We'll decide just now which one. And this question is asking me, how many terms must I add together? That's why n is an unknown. It says solve for n. How many terms must I add together before I get an answer of 1,715? Now, before you can start worrying about the sum, the first thing you have to do is expand so that you've got your first 3 terms. So this is what I'm going to do. My little formula says 3k minus 5. And into 3k minus 5, I'm going to start by substituting in 1, because that's what I'm told to do. So I'm going to say 3 times 1 minus 5. And that gives me an answer of negative 2. Then I'm going to go to the next number, 3 times 2 minus 5, and that gives me an answer of 1. Finally, 3 times 3 minus 5, and my answer is 4. So this is my number pattern. I've got negative 2, then I've got 1, and then I've got 4. So once you've done the expansion, it is important to decide whether you are working with arithmetic or geometric. Now, this number pattern is very clearly arithmetic, as from one term to the next, I am adding. There's another easy way to see. Guys, in your little formulae, I'm going to go, if you have something like, let me do this. If you have something like sum n, it doesn't matter, k is equal to 1, where your k or your p or whatever is in the linear. In other words, it's not an exponent. Then you know that you're going to deal with a linear or an arithmetic number pattern. If you have something like this, where your k or your unknown is in the exponent, you are going to have an exponential or geometric number pattern. Those are, of course, the same thing. So that's a very important tip. So I didn't have to think about it too much. I knew immediately if I've got -2, 1, and then 4 that I'm dealing with an arithmetic number pattern. Now we're coming up to a break, so I'm going to give you guys a bit of a hint, and you can work on this in the break. We're using the sum formula because of that sigma, and we're using the sum formula for an arithmetic number pattern. This is the formula that you're going to substitute into, boys and girls, and our unknown that we're going to solve for is n. All right. So think about that. Let's just go back to the question one more time. The question wants to know how many do I have to add together to get an answer of 1715. So in the place of Sn, you're going to put 1715. In the place of Sn, I put 1715 because I want to know how many terms must be added together before my answer is 1715. Whenever I'm calculating how many terms, my unknown will naturally be n. So n is my unknown. In the place of a, I put in my first term, and my first term in the number pattern was -2. And then in the place of d, I put my common difference, which is what I add from one term to the next. Now, this is all the hard thinking work done. From here on, it's just a bit of algebraic manipulation. So let's get on with that. I'm going to start at the inside of my bracket. So I'm going to say, right, 2 times -2 is -4. Then I'm going to distribute the 3 into the bracket, so that'll give me -3 plus 3n. And that's equal to 1715. Just tidying things up in my bracket. N over 2 gives me 3n minus 7. And all of this is equal to 1,715. Now, at this point, that 2, the n over 2, could be a bit of a problem. And one easy way to get rid of the n over 2 is just to multiply our entire equation through by 2. So I'm going to do that. Let me use another color to indicate that I'm multiplying the entire equation through by 2. So if I multiply through by 2, I get 3,430 on this side. Please feel free to use your calculator. And on this side, I get quite simply n, because the 2 and the 2 cancel, multiplied by my bracket 3n minus 7. I am now going to multiply the n into the bracket, so I get 3n squared minus 7n minus, and I'm going to bring over to this side, 3430 equal to 0. Now, boys and girls, this is a bit of a nasty quadratic equation. We're not all that good with the horrible factors of 3,430. But remember, you can use your quadratic formulae. Now, because Tamlin in our previous lesson dealt with that sort of thing, I'm not going to go through the motions of putting it into the formula. I'm just going to tell you guys what our answers are. You can then use the quadratic formula and make sure that you get the same answers. So just to write down the quadratic formula, at least in case you've forgotten, x, or in this case it will be n, is equal to minus b plus or minus the square root of b squared minus 4ac, everything divided by 2a. So remember that a will be the coefficient of n squared, so that's 3. B will be the coefficient of n, so that's minus 7. And c will be the constant term. And don't forget the signs. It's minus 3,430. Right, so I put these in, and I got two answers, and I'm going to write them down here. I got n is equal to 35, or n is negative 32 and 2/3. Now, last week we spoke about this quite extensively. N has to be a positive whole number because it's like a place in a race. You can say, oh, I had to add 35 terms together in order to get 1,715. You can't say that I had to add minus 32 and 2/3 term together. That's like saying I've got negative 32 calculators. It's just not quantifiable. So what you have to do is you've got to interpret your answer and say n equal to 35 is correct, whereas the other is not valid. Okay, now before we go on to another question, I need to talk to you guys about some of the questions that we had during the previous break regarding that sum where I said for which values of k will it converge. I'm going to make up another one so that you guys can see that they can all be different. I'm going to say 3p minus 2 is my first term. 3p minus 2 squared is my second term, and 3p minus 2 cubed is my third term. Now, the first thing that you have to notice, or write down at least, is the condition for convergence. The common ratio must be between minus 1 and 1. Guys, you need to know this in the middle of the night. If I wake you up and say, what's the condition for convergence? You need to jump up and tell me this. Also, the common ratio cannot be 0. Because anything times 0 is 0, so then it will just go 0, 0, 0, 0. So that doesn't converge to anything. All right, so that's the first thing I do. The next thing I do is I identify my common ratio, and I'm doing this rather quickly, but you should be able to see that from one term to the next, I am multiplying 2p by 2p minus 2. And then substitute that into the place of r, because that is the common ratio. Now what you need to do is solve for your variable. Now somebody said, why am I always subtracting 1? It just happened to be that I was subtracting 1 in my examples. But in this example, in order to solve to get p on its own, what I will have to do is I'll have to plus 2, because I want to get rid of that negative 2 to get p on its own. So now I'm doing that throughout. So you don't necessarily always do the same thing. That gives me 3p is greater than 1, because 2 minus 1, and less than 3. Now, solving for p, again, I'm going to divide by 3. So I'm going to get that p must be greater than 1/3 or less than 1. Right. So it's not always a case of subtracting 1. I subtracted 1 because it was plus 1 in the middle, but now I have minus 2 in the middle, so I had to add 2. And then just the same thing over here, solve for p. We cannot have our common ratio be equal to 0. And if 3p minus 2 is equal to 0, then this is going to be a problem. Sorry, let me just... 3p is equal to 2. And now I'm going to divide both sides by 3. So p cannot equal 2/3. So if you were to put this on a number line, any value between 1/3 and 1 except for 2/3. So this is typically what a question like this will look like. For which values of k will the series below converge? So what do the values of k have to be in order for this series to converge or have a sum to infinity? Right. Now, the first thing that we need to establish is what is our common ratio? In other words, what do I multiply with from one term to the next? Well, the first term is 2k plus 1 to the power 1. The second term is 2k plus 1 to the power 2. And then 2k plus 1 to the power 3. So to me, it's pretty obvious that I'm multiplying by 2k plus 1. If you're not sure, do this test. Let's take the third term and divide it by the second term. The third term You don't have to do this. I'm just proving my point to you guys. The third term is 2k plus 1 to the power 3. So I'm writing it out 3 times just to make it super duper clear. The second term is 2k plus 1 to the power 2. Now, if I simplify this, those brackets cancel, and my answer is 2k plus 1. Now, exactly the same thing will happen if I take the second term and I divide it by the first. Okay, so you don't have to show any of this. If it's natural for you what the constant ratio is, then you don't have to stress. So the first thing we do in a question such as this one is we write down the information that we already know. And this is also on your information sheet. This is the condition for convergence. The common ratio must be between -1 and 1, and it cannot be equal to 0. So that would be step number 1. The next thing that you will do is you will now replace your R with what is your constant ratio in this particular question, and this was 2k plus 1. So I say now 2k plus 1 must be less than -1, sorry, greater than -1 and less than 1. And I do the same over here. All right, so the first step is just to write down the definition. The second step is to establish what your R is, what am I timesing with, from one term to the next, and then to substitute it in. Finally, what we're going to do is we're going to solve for our variable. In this case, our variable is k. So this is how I'm going to go about it. I look here in the middle and I say, well, firstly, I only want to have k in the middle. So what I'm going to do, and I'm going to do it everywhere, I'm writing it in a different color, I'm going to subtract 1. That will give me, in the middle, 2k. -1 minus another 1 is -2. And 1 minus 1 is 0. But now, guys, I have to solve for k. The question doesn't ask me to solve for 2k. I've got to get k on its own. So I'm going to do that. I'm going to divide by 2. So I'm going to divide by 2. And this gives me -1. So what does this mean? As long as k has a value that is bigger than the -1, but smaller than 0, this number pattern will converge. But I've also just got to fix up this side. The constant ratio can't be 0, because then from one term to the next, you'll just have the same thing. So this is going to be, so that will just be 0, 0, 0, 0. So I've got to do this condition as well. 2k cannot equal -1, so k cannot equal -1/2. Now, if I look at that on a number line, and this is not required, I'm just putting it out there for you guys, it means that k can be, well, there's -1, there's 0, and here we'll put -1/2. So k can have any value in that region, but not including -1/2, and then again, any value in that region. And as long as that is true, then the number pattern will converge. Katlego, is this making more sense
I
to our
think this is
viewers?
making more sense to our viewers, hey? They might be a bit quiet, but I think it's because they actually understand.
Right, guys, so just let us know. In the meantime, I'm going to go on to another question. So let's have a look what I've got up here for you guys.
Well, guys, we've come to the end of today's show. Thanks for joining me. Remember to visit our website, learnextra.co.za/live, to get the notes and to watch the videos. And if you are stuck and you have any questions, send an email to helpdesk@learnextra.co.za and we will help you. Also, guys, we are dedicating the month of March to Library Month. Join us as we discuss some great books and some exciting competitions on the way. Goodbye.